Welcome back, students. Today we would be learning how to find the radius given the intersection of two chords. So we have here AB being a chord and CD being another chord. Both of them are intersecting. We have been given U to be as 3, V to be as 4, T is not given, W is given to be as 12. We are expected to find the radius of this circle. Now, foremost, we would be employing this formula, which is 4 times R squared is equal to U squared positive V squared positive W squared positive T squared. Now, I would show you how exactly we got this formula, and the link for this video would be available on this video. You can just do a small review on this formula. So having said that, let us now obtain the radius for the circle. Now clearly we got U, we got V, we got W, but we don't have T. Now by using the power of a point formula for intersecting of chords, clearly we can write U times V to be equal to T times W. Now my U is 3, my V is 4, my T is not there, and my W is 12. So clearly I would be able to get T from here, which is going to be 12 over 12. Therefore, the value of T is 1. So having obtained the value of T, using this formula, from 1, we can now have 4 times R squared is equal to U is 3, that's going to be 3 squared. V is 4, that's going to be 4 squared. W is 12, that's 12 squared. Of course, T we have already found, that's going to be 1 squared. So now simplifying, 3 squared is 9, 4 squared is 16, 12 squared is 144, 1 squared is 1. 9 added with 1 would give me 10. Positive 16, positive 144. So 10 added with 16 added with 144 would give us 170. So 4 times R squared is going to be equal to 170. So R squared is equal to 170 divided by 4. So 4 can divide 170, 42.5. So from here we got R squared to be equal to 42.5. R would be root of 42.5. You can use a calculator and obtain the value for this. Welcome back, students. I would be showing to you how is 4 times R squared is equal to U squared positive V squared positive W squared positive T squared. Now you have to know this important theorem which states that the center of a circle is always along the perpendicular bisector of a chord. Okay, have that in mind. So having said that, if I were to drop a perpendicular bisector to this chord, I have already taken this to be as AB and CD. If I were to drop a perpendicular bisector, then the chord would hit exactly at this point, the midpoint of AB, right? So we have to know this distance, right? So let me draw this circle. This is the chord AB, and we got a chord CD coming here, and this is going to be u. This distance is going to be w, this entire part. Okay, so the chord is bisecting AB at this particular point. So this distance should be w plus u divided by 2. So that is this distance. So I'm talking about this distance. Okay. Now, having got this distance, I'm interested in knowing this distance. So this distance would be w minus u divided by 2. Now, we need to drop a perpendicular bisector to the chord CD. So if I do that, then that chord, which is a perpendicular bisector to CD, would intersect the other perpendicular bisector exactly at the center. So we have this distance, which is w minus u over 2. So this distance would be, this entire distance is t. So this is going to be, I'm writing it down here, t positive, this distance, v over 2. So that would be this distance. Okay, now I'm going to be connecting this point exactly to the center. So that would mean this will be my radius. So from Pythagoras, we know that t positive v over 2 square positive w minus u over 2 square would be equal to r square. So that is from Pythagoras law. Okay. So from this theorem, we have this. So now let us expand this. So this is going to be t squared positive 2 times tv positive v squared divided by 4 positive. So if we were to expand and putting them together and moving the 4 out, we would now have t squared positive v squared positive w squared positive u squared positive 2 times tv negative 2 times uw is equal to 4 times r squared. Again, clubbing them, t squared positive v squared positive w squared positive u squared positive 2 times of tv negative uw will be equal to 4 times r squared. Now, by the power of a point formula for the intersecting of chords, we would have tv to be equal to uw. So this means tv negative uw will be equal to 0. So this entire term can be cancelled, thereby giving us 4 times r squared is equal to t squared positive v squared positive w squared positive u squared. Of course, we can rearrange it as u squared positive v squared positive w squared positive t squared is equal to 4 times r squared, or however way you want it to be arranged depending on your convenience. So thus we have proved this important formula